Welcome in a new video. In this video, we will discuss some important questions from previous papers. Questions of derivative from previous papers. So let's start. We are given with the equation xy plus y square equals to 0 and we have to find out the value of dy by dx. So let's differentiate this equation, that is xy plus y square equals to 0. Let's differentiate this equation. First of all, take d by dx xy plus d by dx of y square. This question is a little bit different from the previous question, but it's also very easy. You can see that here is a product of two functions x and y. So we can differentiate with the help of product rule. Take the derivative of first function and second function will remain as it is plus. First function will remain as it is and find out the derivative of second function. As second function is y, so its derivative is dy by dx, because the derivative of x with respect to x is 1, y as it is plus x, dy by dx plus, as you can see here is y square, so we can apply power rule. Place the power on start and reduce the power of given function by 1 and take the further derivative. Further derivative of y with respect to x is dy by dx. Okay, plus 2y dy by dx equals to 0. Y plus, as you can see, dy by dx is common in these two terms, so let's take it common from these two terms. So here it remains x plus 2y. As we have to find out the value of dy by dx, that is why we have separated it from all the terms. So now our equation becomes dy by dx into x plus 2y equals to minus y. We have to find out the value of dy by dx, so let's separate it. Dy by dx, it will become minus y over x plus 2y. So you have observed it's also easy. Just one thing that is different from other question is that you have also have to find out the derivative of y, as whenever you have to find out the derivative of y with respect to x, its answer is dy by dx. For example, whenever you have to find out the derivative of y square, you can use power rule. You are finding the derivative of y with respect to x, so place the power on start, reduce the power by 1 and further derivative of y with respect to x is dy by dx. In this way easily you can find out the derivative of y. So let's discuss another important question from the previous paper. We are given with a function. We have to find out again dy by dx, and we are given with a function y equals to x cos y, and we are asked to find out the derivative of given function. So let's start. First of all, here it is y, and here the function, you can see here it is a product of two functions. First function is x, we can say it f of x, and second function is cos y, we can say it g of x. So we can use product rule to find out the derivative of this function on the right hand side, and on the left hand side we have y, so differentiate y with respect to x, so it becomes dy by dx equals, here we will use product rule, take the derivative of first function and second function remains as it is, plus first function is as it is, and take the derivative of second function. Here derivative of x with respect to x is 1 and cos y will remain as it is. Now x is as it is and the derivative of cos is minus sine y, and the further derivative of y with respect to x is dy by dx. Let's simplify it. Cos y plus and minus, it will become minus x sin y dy by dx. On the left hand side there is also dy by dx. dy by dx is common in these two terms, so let's combine these two terms. Dy by dx plus x sin y dy by dx equals cos y. Let's take dy by dx common from these two terms. Here it remains 1 plus x sin y equals cos y. What will be the answer? Dy by dx equals cos y over 1 plus x sin y. So you can see it. You can see that these questions are quite easy, and you can easily attempt these questions in your papers by practicing. This time we are given with the function y equals x e power sin x. You can say that in the left hand side again there is a product of two functions. First function is x, so take the derivative of first function. Derivative of y with respect to x is dy by dx. Now take the derivative of x with respect to x, and second function, that is e power sin x, is as it is, plus first function is as it is, and take the derivative of second function e power sin x. Now the derivative of x with respect to x is 1 and e power sin x, plus x, and the derivative of e power sin x is as the derivative of exponential function. First exponential function will remain as it is, and further take the derivative of power, as in this case power is sin x, so take the derivative of sin x. Let's simplify it. Sin x plus x e power sin x, and the derivative of sin x is cos x. In this way you can find out. Now as e power sin x is common, so take e power sin x common from these two terms. Our answer is 1 plus x cos x. So this is the derivative of your given function. So let's discuss our next question. This time we are given with the function x square minus 4xy minus 5y equals to 0, and we have to find out the value of dy by dx. So let's differentiate the function with respect to x. So as the given function is in the form of difference of two and more than two functions, so let's take separate derivative of each function. D by dx of 4xy minus d by dx of 5y equals to 0. Now derivative of x square with respect to x is, as you can use power rule, place the power on start and reduce the power by 1. Now as you can see, this function is in the form of product of two functions, but before you are going to take the derivative by product rule. First place the constant, just place the constant on start, and now take the derivative of x y minus, as you can see again this function is a form of ax where 5 is a constant, so place the constant on start. As usual, take the derivative of y, and the derivative of y with respect to x is dy by dx. Now 2x minus 4. Now differentiate with the product rule. Derivative of first function is 1 and second function will remain as it is. Now Again, first function will remain as it is, and we find out the derivative of second function, that is dy by dx. Understood? That is dy by dx. 5 dy by dx equals to 0. Hope you are enjoying these questions. These are a little bit easy questions. You can easily attempt these questions in your papers. But first make the practice of all the rules related to derivative. All the rules that we use while finding the derivative of different functions. Now our equation become 2x minus 4y minus 4x dy by dx minus 5 dy by dx. As you can see, again dy by dx is common in these two terms, so take dy by dx common from these two terms. Dy by dx, what will remain here? It will remain 4x plus 5 equals to 0. Now minus dy by dx into 4x plus 5 equals, here you can see, here it is plus 2x, and there it will become minus 2x and plus 4y. Now our answer is dy by dx equals minus into 2x minus 4y over minus into 4x plus 5 only. So minus will be cancelled, so our answer is 2x minus 4y over 4x plus 5. It's so simple. In this way you can find out the derivative and also the value of dy by dx from your given functions. Now this time we are given with a function y is equal natural logs x square minus 1 over x square plus 1 whole power 1 by 2. Here you must have to be tricky. In order to solve it, you must have to be tricky, otherwise you will face difficulty while solving it. So first logic is that here is natural log in the start, and rule is a natural log is that whenever there is a power in the function that is next to natural log, so the rule is that place the power on start. So before finding the derivative, before starting the derivative, apply the rule of logarithm, that is place the power on start. So place the power on start, so our function becomes 1 by 2 natural log x square minus 1 over x square plus 1. In order to make it more simple, apply next rule of logarithm, that if there is a function that is in quotient next to natural log, okay, a function is of the type f of x over g of x is in quotient next before natural log, so the rule is that place it in difference of two functions. So it will become x square minus 1 minus a natural log x square plus 1. The rule is that if the function next to natural log is in quotient, so place it in the difference of two functions. Similar to this as I have written. Okay, next, now we will start finding the derivative of this function. Okay, next here it will become differentiate y with respect to x, then it will become dy by dx 1 by 2, as this is the difference of two functions, so take separate derivative of each function. Dy by dx natural log x square minus 1 minus d by dx and natural log of x square plus 1, in this way, just simple. Okay, 1 by 2. Now you know very well what is the rule to find out the derivative of natural log of x or any function that is next to natural log. We place in the denominator that 1 by x square minus 1, and we will find the further derivative of the function, that is further derivative of the 1 is 0 and x square is 2x minus, again any function that will be next to natural logarithm, just place it that function in the denominator here, just like this, 1 by x square plus 1, and take out the further derivative of x square plus 1, that is 2x, and the derivative of 1 is 0, so we are not writing the 0, just skip it. Okay, next the next step is 1 by 2, that is 2x over x square minus 1 minus 2x over x square plus 1. You can write it as similar as 2 is common, 2x is common in these two terms, so we can take it common. Just take 2 common from these two terms, and here it will become x by x square minus 1 minus x by x square plus 1. Now 2 is cancelled with 2, as these are two rationals, so you can solve it simply as x square. In the denominator we will put x square minus 1 and x square plus 1. Here it become x into x square plus 1 minus here it become x into x square minus 1. It's so simple. So write x cube plus x minus x cube plus again x. Okay, and in the denominator x square minus 1 and x square plus 1. X cube is cancelled with x cube, and our answer is 2x over x square minus 1 into x square plus 1. It was a little bit lengthy, but not difficult. It's too easy. So just try it. Now this time we are given again with a tricky function, that is y equals cos square root x and plus square root sin x. Here you can see our angle is square root x plus this whole function is in square root. So just have a look on it. Okay, also you can see these two function is in sum. So take out the separate derivative of these two functions. Dy by dx equals d by dx and cos square root x, and you can write it as sin x whole power 1 by 2. You cannot write cos square root x because the square root is only on angle, but here the square root is on the whole function. So you can write sin x whole power 1 by 2. So let's differentiate it. As the derivative of cos x is minus sin square root x, and you know very well we have to find out the further derivative of angle, that is square root x. Plus here first of all you have to apply the power rule. So what is the power rule? Place the power on start and reduce the power by 1. So it powers become minus 1 by 2. Now further take out the derivative of the given function, that is sin x. Now our equation becomes sin minus sin square root x, and the derivative of square root x, as again apply the power rule, place the power on start and reduce the power by 1. It becomes minus 1 by 2. Whenever you have to reduce the power of 1 by 2 minus 1, just here it becomes 1 minus 2. So our answer is minus 1 by 2. So don't confuse from it. Okay, 1 by 2. As here in the power is minus 1 by 2, you can write it in the denominator square root sin x. Now further derivative of sin x is cos x. Now our equation becomes minus sin square root x over 2 square root x, as again the power of x is minus 1 by 2. So you can write it in the denominator, that square root x. So again plus cos x by 2 square root sin x. This is the derivative of the given function with respect to x. Now this time we are given with a function e powers minus x into x cube plus 2x power minus 2 plus 1. You can again see that these two functions is in the form of, our function is in the form of product of two functions. Just like first function is e power minus x, and second this is the second function. So we can apply product rule, take out the derivative dy by dx, take the derivative of first function, and second function will remain as it is, that is x cube plus 2x minus 2 plus 1, plus first function remains as it is, and take the derivative of second function, that is x cube plus 2x power minus 2 plus 1. Now the derivative of e powers minus x is, as the derivative of exponential function remain as it is, and we will find out the further derivative of power. Here in this case the power is minus x, so our derivative will be minus 1. So x cube plus 2x minus 2 plus 1 plus e powers minus x and derivative of x cube, and we will take separate derivative of each terms because you can see this is the sum and sum of two functions and also a constant function. So derivative of x cube is 3x square and the derivative of 2x power minus 2, place the power in start and reduce the power by 1, so it's become minus 3, and derivative of 1 you can know that you know very well derivative 1 is always 0 because 1 is a constant function. So next e powers minus x, and this I will put this minus on start, x cube plus 2x power minus 2 plus 1 plus e powers minus x, and here it becomes 3x square minus 4x power minus 3. Now you can see e powers minus x is common in these two terms, so it's same in these two terms, so just take it common from these two terms. Here it will become minus x cube minus 2 x power minus 2, that minus 1 plus 3x square minus 4x power minus 3. Now our equation becomes, here it is minus x cube and it is minus 4x cube, so it becomes minus 5x cube and minus 2x power minus 2 plus 3x square minus 1. This is the derivative of the given function. So these were the some important questions from your previous papers. The first step to easily solve the derivative is to learn the rules. Second thing is that just practice each and every rule. Just practice each and every rule. Then you will be able to easily find out the derivative of any given question. So I hope that you may now got the idea to find out the derivative of different questions.